Right on time. Thank you everyone for coming here. My name is Ray. I'm a developer advocate for the Google Cloud Platform. And it's my first time here at Øredev and also in Malmo. So very happy and honored to be here. I'm a developer advocate for Google Cloud. What that means is that I like to bring some of the latest and greatest technology that we have to offer to developers all over the world. But I also like to hear about your use cases and see what we can do to make our projects better and our products better overall. So if you have any questions, any feedback, please reach out to me on my Twitter at Satanism. Okay. And just in case you don't know about Google Cloud, we have everything from compute to big data to machine learning and all that. Aside from developing applications and being an engineer, my other passion has been traveling. I love to travel and I love to take photographs. This photo is very special to me because I took it while I was on a 4-month trip around Asia. And in one of the cities, they didn't have a place for me to stay because it was very expensive and I was a backpacker. So I didn't want to pay the money. So somebody actually said, hey, you can actually go out to a desert, okay, and hike in the desert for about 4 hours. And then you will actually find a real oasis and you can stay there for free. And as a backpacker, I thought, free? Well, sign me up, let's go. I didn't think twice about water or am I gonna survive. How many people here hike in the desert before? There's always 1 or 2 people, yeah, see? By yourself? No, kinda, yeah. But you all walk on the beach, yeah? Yeah, on the sand? It's not the same. It's not the same. Every step that you take, you kind of sink a little bit into the sand, and you have to pull yourself out. But the worst thing is, when somebody tells you you need to walk in the desert for 4 hours in one direction, you kind of lose track of where you are, and it's really tough because halfway into it, you have no idea where you are. How many people here are Java developers? Okay, a significant number of you. So, honest story, when I was going through this, I thought that I was writing a J2EE application the whole time. And yeah, if you're not a Java developer, ask one of them that raised their hand, and they will tell you why. Anyways, if you like to see some of my travel photos, you can go to my Flickr. I got tons of them. And today I'm going to talk about building fast and efficient microservices, but mostly it is because that while we were in the world of monolith, and there has been a lot of talks about the microservice architecture and all that. I'm not here to talk about the theories and why or why not you should be moving into it. But if you do decide that microservices architecture is good for you and it solves your problem, then the first thing that's going to happen is you're going to have all of these tiny, smaller components flying around everywhere. And you need to be able to manage them. It's not easier, right? It doesn't get easier to solve problems. It might actually get harder and more complex. And when you have all of these components that you have to deploy and manage and operate, this deployment process becomes very hard. And you need the right toolings to avoid some of the issues like versioning and deploying the wrong instances, or just being able to manage 100, 200 instances in your environment. Now, fortunately, we have a way to do that today. It was not there before. You are able to use containerization technology to package not just your app, but also your runtime environment. You are able to use orchestration tools like Kubernetes to help you orchestrate and deploy and manage these applications across a whole cluster of machines. This becomes a trivial job to do. But if you're using scripting, if you're trying to do this manually, it might not work well for you, right? But that is a solved problem. But one of the biggest problems that nobody asks, up until recently, is how are these services supposed to talk to each other, right? Before, everything was in memory. You just communicate with each other in the same machine. Now you have to go across the wire. You have to potentially go across the network boundary. But how are you supposed to communicate, right? I think that RESTful services has been the default choice. But if anyone here has gone through the age of, say, SOA, service-oriented architecture with SOAP, right? SOAP was the default choice. And I think that very few people ask the question of, is there another alternative to it? And how can we make it better? And so we are kind of stuck. Now, This talk is about gRPC, and it is a RPC framework, and that's remote procedural code framework. And it actually sounds very familiar. This RPC thing is not new. People have been building distributed system for a long time, or SOAP, web services for a long time. But why are we talking about this again? I thought REST is the default now, and this is settled. Well, how many people here actually remember Corba? Usually people who raise their hand runs out of the room by this time. I'll show you a little bit about Corba. I found this really, really awesome tutorial. If I ever need to do Corba again, this is the thing I will use. But basically, with any of the RPC systems, you will probably start off with an IDL, like an interface definition language. This IDL is supposed to capture the type of operations you can call remotely, and also the message payloads that you can actually use. In REST, even though this is not strictly required, but in REST, I think a lot of people are discovering you can't just make up any payload and send it over. You actually need a descriptor, and so people are using Swagger or other things to describe what that REST service look like. In SOAP, we use WSDL. In many of the RPC systems, we have IDL. Very similar. So this example adds two numbers together. It's just simply adding the A and the B. Now, pretty easy. So you define this interface. Okay, and then what you do is you usually generate the code. So with RPC system, you're usually able to generate the stubs. So you don't actually have to remember what to type when you want to implement. Or the best thing for me is that it can usually generate a client library. So you will never send the wrong field or type the wrong letters, the wrong characters to be sent in on a text-based protocol. Right. So here, there's they actually generated the stub. And then they implemented addition, which is pretty simple, right? This is how you implement a server. But with the RPC systems, they usually need like a process, a wrapper process that starts this whole server. So in Java, that's no difference. You actually need to write the code to start the server. So let's move down a little bit, and this is where they lost me. By the way, this is just adding two numbers together. So like all of these things are a little troublesome, right? With Corba, the reason that it was not really popular is because it was pretty hard to do. And there are other issues, obviously. But again, this thing is not new. We have DCOM, we have something easier for Java developers like RMI. RMI is very easy. You can write Java code the way that you want, and it automatically exports it to a port, and you can code that interface or operation from a remote consumer. But the problem with RMI or that kind of technology is it is not very interoperable. If you only use Java, it is perfect. But if you ever need to use something else that's new, like recently, like Node or Go or Python, whatever, then it becomes a little bit harder. Even with SOAP, why is SOAP in RPC? SOAP actually has two styles. SOAP has a document style SOAP, which is more like REST, and then you have the RPC style SOAP, which is more like RPC, right? But why RPC? Why are we talking about RPC today? Well, in general, RPC is going to be definitely more efficient than a text-based protocol like XML-based payload, or in RESTful case, a JSON payload, right? Because it's binary. It has to be smaller and more efficient to marshal and unmarshal. RPC is usually strongly typed. What that means is from the IDL, you can define the types concretely. And when the client libraries are being generated, they are strongly typed. So it's very hard for somebody to use RPC in a strongly typed language to make a mistake in terms of, oh, sorry, I sent in the wrong data. And also, most importantly, in a RESTful service, if you want to do strict REST, you are stuck with the HTTP verb and HTTP semantics on the resource. What that means is you have to use something like the get, the put, the delete, right? And that really maps to the CRUD operations of an entity, of a resource. That is great for resources, but if you ever have a more complicated operation, a business operation you need to implement, then it gets a little harder, right? So for example, if I want to transfer your own money, all of your money, into my account, what do I do with REST? Do I patch your account first and then patch my account later? Or do I say transfer? That would be potentially a lot easier. But transfer is not exactly RESTful. So what do you do in this case? So in many of the cases with RESTful services, people cannot fall back to an RPC style JSON-based operation anyways, right? So RPC can be great. It can be good if and only if, in my mind, that it is simple to use and it is interoperable. So it's got to be significantly easier to use than Corba and tons more interoperable than RMI. Okay. So at Google, we do use multiple languages, and we do have microservices, and we do have to do these across the wire communication. And at Google, we use our internal technology called Stubby. Stubby is a RPC framework that's being used by us very extensively. In fact, we make about 10 to the 10 RPC calls per second today within our data centers. Right now, there are 10 to the 10 RPC call going through the services. Okay, so Stubby was actually designed to be efficient. Imagine if every one of these calls takes 1 extra byte. That is 10 to the 10 more bytes that we have to transfer. Now imagine if all of these transfers are being done through JSON. That is a lot more bytes that we have to transfer in. That is why Stubby is used extensively, and we've been developing it for a while. And that brings us to gRPC. gRPC is basically the open source version of Stubby. And by the way, what does gRPC stand for? The G in gRPC does not stand for any company I know of. You're saying, yeah. It is a recursive acronym. It is gRPC stands for gRPC Remote Procedural Code Framework. All right. And it was actually open source, not just by Google. It was actually open source in conjunction with Square, another company, a payment company that was looking into an RPC solution. And this collaboration actually works really well. It is simple to use. It is idiomatic to the language that you want to use. It is designed to be performant and scalable, like Stubby, because it is the same experiences. And it is more interoperable. Now, fundamentally, there are 3 things I want to talk about today, and then I'll show you the demo. Well, first of all, we need to understand the IDL, right? There's an interface definition language, which is using protobuffer 3 as the language of choice. So you can define your payload and also the operation with protobuffer 3. And then you can compile using protobuffer 3 into the target payloads for different languages. So in Java, we'll generate the classes for your payload. For C#, we'll generate the classes there for C#, and so on and so forth. And also the binary format is also protobuffer 3. So it's a very efficient format. We're going to see it in a bit. But more importantly, our gRPC is built on top of standard protocol. So rather than building our own TCP protocol, right, on top of TCP protocol, we're just using HTTP2, which is standardized recently. And HTTP2 offers tons of efficiencies over HTTP 1.1, or the protocols that we're using today. So how many people here already use HTTP2? No. Yeah, well, some of you actually do. If you go use like a modern browser and go to google.com, you're probably making a request via HTTP2. It's just nobody told you that, right? There are many sites are using HTTP2 today. And but what is HTTP2 and why do we choose it? HTTP1 has been around for a long time. It is text-based protocol. I mean, if you think about technology, HTTP 1.1 has been around for more than 10, 15 years or something like that. It's been there forever. My phone don't last for more than like 2 years for that matter, right? So HTTP 2 was basically designed to be in the next generation of HTTP protocol and designed to be tons more efficient. First of all, in HTTP 2, it's completely binary. Okay, in HTTP 1.1 or 1, what you can actually do is you can telnet to a server, right, on port 80, and you can type get space / blah blah blah, and that's how the browser is transferring all the text. Well, in HTTP 2, all the get, you know, the things that we know can be enumerated, they are turned into just a byte. So rather than sending 3 bytes for the get operation, maybe just send 1 byte and be done with it, right? So what that also means is you cannot just use, you know, telnet to get into your server anymore. You actually need to use a proper client. In the HTTP world today that everybody operates in, you know, if you need to ever string the data between the servers, what do? You either need to do server sent event from server to the client, or you do WebSocket, right? in HTTP 2, streaming is actually built in. This is awesome. What that means is you can open up a connection with a regular server, a HTTP 2 server that supports it, right? And you can stream. You can stream from the server to the client. You can stream from the client to the server. You can also stream both ways. So you can do bidirectional streaming. In fact, what you can actually do is before the client even asks for something, you could stream that like CSS or image to the client proactively because you know the client will ultimately ask for it. You can just stream it. More importantly, HTTP 2 also supports multiplexing. It's multiplexed by default. What that means is in the past, in HTTP 1.0, which nobody uses today, I hope, when you want to make a request, you got to open the connection. If you want to make a second request, you either wait for the first request to complete or you open a second connection. That is because the request and response is serialized, it's linear. So you make the first request, you wait, and then you make the second request, and then you wait. Or you open multiple connections. That is not very efficient in terms of establishing connections, right? Because if you need to establish new connections, there are TCP handshakes and all that, there are overhead. In HTTP 1.1, we have pipelining. This is a mechanism where you can send multiple requests at a time, right? You can say, I want A, B, and C, and in parallel, basically. And then you should be able to get it back in parallel too, but you don't. The responses that you have to get back has to be in the order of how you sent out the request. So for that matter, if ABC is what you want, and BSC only takes 1 second, but A, the first request takes 10 seconds, well, you have to wait for 10 seconds before you can get back the other two results. So there are still issues there. And this is what we call head of line blocking. This is basically the slowest, the first request you actually have to wait. In HTTP 2, like I said, we do multiplexing and we can stream data. What that means is rather than being blocked, you can actually just send data as you wish. Okay, so people are not blocked by a slower process or slower request anymore. And the way that we do it is by basically segmenting or carving up the payload data into multiple frames. And so rather than sending the entire block of response as a single response that you have to wait to get back, we can cut that response up into smaller chunks or different frames, and then we can multiplex different frames onto the same stream. What that means is with just one connection, we can handle all of the requests. You no longer need to open up multiple connections or dealing with that kind of overhead anymore. And just to show you what that looks like, here is a HTTP 2 demo. Oh, that was really fast. So if I refresh, it's going to load HTTP 1 first. And if I run the HTTP 2 test, you can see that even though they are both under a second, but if you look at the percentages, this is significantly faster already. On Wi-Fi, this is even faster when I tested earlier. Okay. There's another thing that HTTP 2 can do, which is header compression. If you ever open up your HTTP 1 payload, you're going to see the headers. You see the cookies, or I don't know, the host, the path. There's just tons of agent, user agent, for example, tons of headers. Most of them don't change. Most of them are the same throughout the lifetime of the session, right? In HTTP 2, we use HPAC for header compression, and what that actually means is that we will keep an index of all the headers values that we have seen before, and then rather than resending the same header values over and over again, we can just send in the index for the values that we already had before for your connection. So this actually cuts down in terms of the amount of data that you need to send a lot. Okay. So how much faster though? How much faster is gRPC? Well, if you compare it to a RESTful protocol or a text-based protocol, in this case with JSON over HTTP, of course it's faster, right? In this case, the throughput is 2-3 times faster or better than JSON over HTTP. But that's expected. I mean, we're sending smaller amount of data, but more of it, right? To accomplish more, basically. But what is really interesting to me is this one. Per CPU throughput is significantly better. And if you're looking into building a cloud-native application, or if you decide to actually run in the cloud, CPU is what we charge, right? You have to pay for the amount of CPU that you use. And so the more efficient you are with the CPU, the better for your projects that you're trying to implement. But more importantly, in mobile devices, this is also the case. In mobile device, you want the user to be able to send less data so you don't eat up their bandwidth. You want to be able to get the data back much faster, so you need smaller payload. And you also want to save them battery, and so you want to be more efficient when it comes to using the mobile power. Okay? We do support multiple languages. C++, Objective-C, Java, my favorite. I do want you to focus on three of them. It's Objective-C, C#, and Java. The reason is because these are the mobile languages as well. You can actually target most of the mobile platforms. You can use the mobile clients that's using gRPC behind the scenes. So this is very, very cool. All right. So without further ado, let's see what we can do to build a gRPC application. So I'm gonna do some coding here, just so you can see and feel it. I got all the examples online as well. I'm gonna show the slides and the links later. But so here we go. So this is a Java application. I only know Java and Perl. Sorry. So in this case, I will use Java, but the concepts are very similar for all of the other languages. So first of all, you need to create the IDL. You need to create the interface definition language. Okay. And it is a profile because you're using protobuffer 3 language to define. So first of all, we need to set the syntax. Let me just make this bigger. There we go. First of all, I'm going to set the syntax to proto 3. That is because there are multiple protobuffer versions and they are all .proto. So you gotta differentiate which version am I talking about right now. So I'm gonna use proto 3. The other thing you can set is the package. You do need to show the package name, right? Just like Java, you have package names. In Node, in other things, you have namespaces. So this is very, very similar. So it actually maps to a Java package as well if you use Java. There are optional settings that you can set. So the thing is, there will be a generator, or some people call them a compiler, a proto-C compiler. What the generator will do is to take this file and then convert it into the language that you want. And when this generation process happens, there are different settings you can modify. So for example, by default, it's going to generate everything for Java into a giant Java file. And I don't like that. So I can tell the generator a different thing. I can tell it to do Java multiple files is equal to true. And there are different settings for different target languages that you want to generate too. I'm only doing Java, so that's what I'm going to do. Once you have the basic metadata set up, then you can actually just define the message payloads and the operations. So first, you have to define payloads. It doesn't matter if your operation doesn't respond to anything. You still need to have an empty payload. Okay. So first, let me define a request. And in this request, I'm just going to define a few fields, right? So for example, I can have a field called name. As you can see, this is strongly typed. So people can only send string into it. And for every field, we actually need a tag. Okay, so I'm going to define another field with a different type with age. And you need to define a tag. These numbers are very important. These tag numbers are unique within the message. Okay, and what they're being used for is to uniquely identify the field that I need to send data into, right? What that means is in JSON, right? Rather than in JSON, you will be sending a payload like like name is Ray, and you do this over and over again for every payload you have. In gRPC, in protobuffer 3, it's going to be encoded into just 1 byte, and then maybe the data behind it, right? So rather than sending, say, 4 bytes for name, it's just going to send us 1 or 2 bytes for the tag, and that's really it. We can also do strongly typed maps as well, right? So for example, you can have a map or a dictionary that has the string for the key and the string for the value. I'm going to say bag of tricks, for example. And live coding is definitely not one of them. So I'm going to say 3. I can have hobbies. So I can do something like a list of strings. So like a repeated string. That would be a list of strings of hobbies equals to 4. We can also do enumerations. So these are just types, values you can choose from. So for example, just like the Java types, enum, and I can say sentiment. This is how you are feeling right now. I feel a little happy, so I'm going to say happy is equal to 0. You look a little sleepy. So I'm going to say sleepy is equal to 1. And you could be extremely angry at me for spending an hour here with me. So I'm going to say angry is equal to 2. And of course, you can use these enum types just like any other types. Sentiment is equal to, and I'm going to say 10 in this case, right? And there are many other types you can use, and there are many other constructs you can use. But I'm going to stick with this for now, okay? And that's all you need to do to define a message payload. And so for the response, you also need to define the response. And I'm going to say hello back to you. And so I'm going to use a attribute here called greeting. I'm going to set the tag number to 1. Once you have the request and response, then you can actually define your service and operations. So I'm going to say create a new greeting service, okay? And in this service, I can add as many RPC operations as I want. So operations are defined like this. You say RPC, standing for RPC operation. I'm going to have a greet method. And I'm going to take in the request as the hello request as the request. And it returns hello response, okay? And if you want to have more RPC operations, you just keep on adding onto it. Now, this is what we call unitary request and response, because you send in one request and you reply one response. Now remember, even if you don't want to respond with anything, you still need to create an empty response. Okay. Now, if you want a string, it's very easy. If you want a string from the server to the client, you add string to the response message. Now it becomes server-side streamed service. It's not just like that. If you want a string from the client to the server, like in an IoT device where you need to send telemetry data, continuously, then maybe this is a good use case for you to stream from the client to the server. If you want to build like a two-way communication, like a chat, you can just stream from both sides. Now you have bidirectional streaming. It's very simple to define. Now, once you have this IDO, the next thing you need to do is to generate the code. Okay, so usually you will need to download like a Proto-C, like a Proto-C compiler. That's what they call it, or a Proto generator. The thing about the generator is that they're compiled natively onto the target environments. What that means is, if you're running on Mac, you need to download the Mac version of the generator. If you're running on Windows, you gotta download the executable version of the generator. But I'm in Java right now, and we can actually do this automatically. So I'm going to go to the GitHub repository for gRPC. No, not that one. That's all the issues. Let me hide that from you for a second. Yeah, the 300 issues. Yeah. No, it's actually being used in production quite a bit now. So first of all, we need to add the dependencies. Okay. So these are just the dependencies that we need to use for gRPC, and I'm using Maven, so we just define it this way. How many people here use Maven if you're using Java? Okay. Gradle? Gradle, good. Ant? No? There's always somebody. Yeah, there we go. He's waving. Yeah, I'm using it. Makefile? I use Makefile all the time. Makefile? All right, not today. So if you're using Gradle, it's going to be a lot shorter, just so you know, like boo. And so with the generator, if you're using Java, for example, you can actually just add in a few plugins. In this case, I can add in an extension. What this extension does is to figure out what operating system I'm building from. It's not to say the output is not system dependent, but the generator itself is. So what that means is I need to determine what operating system I'm operating on, and then I'm gonna go ahead and download. This actually downloads the right generator for you automatically. Okay, and with that, I should be able to go here. I'm going to do a Maven Clean. Okay, and I'm going to Maven Build. So I'm going to build the app. Now with the Maven plugin here, we also tie this into the execution phases. So whenever you try to compile the code, it's going to try to generate the code as well. And with that, I should have target, and I should be able to see generated sources, and I can see protobuf, and I see Java, and here I see all the request and response types that I have previously defined. So now this just can be used. This is very simple. Okay. Now I have all the types defined. I also generated the stubs. Then I can actually go ahead and implement the server. For that, I do need to go back to that Corebot tutorial to see how that works. No, I was kidding. No. So I'll show you how easy it is on gRPC. Well, first of all, you do need to implement the operation that you just defined. So I'm going to define a new class, a greeting service impo. Oh, sorry. Did I just miss class here? Wow, rookie mistake. And then I'm going to extend the base class that's being generated for me, and that's a stub. So I can extend this import base, and then I can just go ahead and implement the method, the operation I want to implement here. Now, the first side for me on this particular signature is a little special. That is because in the proto file, it's clearly a request and response. However, in Java, what we would expect will be hello response in the response side, and then the method, and then hello request, right? That will look natural to me, but this signature is not. That is because on the server side, everything is implemented asynchronously. It is up to the client to decide whether the client wants to block or not. So if you implement everything on the server asynchronously, not only is it better for performance, but you also don't force the client to block when they don't want to. Okay? And because it is an synchronous signature, you need to send the data back via a callback. And the callback interface is response observer. What that means is, well, first of all, I can see what the request came in. We implement all the to string, for example, so you can see what's actually being sent. But if I want to send something back, I just use the response observer, and I say on next. Okay, and that will send one payload back. And so I need to create a new response object. And because this is gRPC, and all the code is basically using the builder pattern to be immutable. So what that means is I need to code something like set greeting, right? I can say hello, and request.getName. Okay, and that's it. And then build this response, and we send it back. So as soon as you call response observer on next, this payload is scheduled to be sent back to the client. Are we done? Not quite, not quite. Because it is asynchronous. So the server actually don't know when your process is done sending data. It needs an explicit signal. So even though we know this service should only send one response back, it's very possible for you to send two. And if you do it this way, you're going to get a runtime error. If you don't terminate this response explicitly, then the client will actually hang forever. So what you need to do, very importantly, is that whenever you're done, you gotta call uncompleted to signal the server and the client that you're done with the stream and you can actually close. Okay? And that's pretty much it to implement it. And now I need to implement the server, and this is very, very easy. With everything in gRPC, in Java, use a builder. So how do you create a new server? With a builder, of course, and then you just need to say which port you want to listen on port 8080. You add the implementation service that you want to serve, and you just build. And so let me do static class. There we go, much better. And then you can just assign this server to a variable, and then you do have to start it, so you call server start. Now, what this will do is to start the server in a background thread, and that's no good because if this is in a background thread, my primary thread is going to quit, and I would not be able to serve anything. So I need to block my primary thread, and to do that, I just call await termination. And that is all you need to do to write a simple gRPC server, I think. How many people think this is it? This will actually just work? Wow, nobody. Oh, this is a tough crowd. Really? All right, I don't trust myself either, so only way to find out is to actually run it. So let's see, exec Java. So I'm going to do this crudely. I'm going to say package install, blah, 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 and let's see. Huh. I'm just kidding, this is working. Remember, we're not printing anything, so there's nothing that's being printed. Okay, so we're just hung. Yeah? Good? All right. Now, well, thank you very much. I guess I don't need to test this anymore. This works, of course. This could also work if you just say thread.sleep forever. Anyways, so let's try out. We have to find out if this works. So for that, we are going to implement the client. Okay? So I'm going to implement the Java client. You can implement the client in any of the supported languages. And this is what we're going to do. First of all, in Java client, we're going to abstract all of these TCP connections and HTTP connections away from you. You don't need to know any of that. You just need to know what endpoints you want to connect to, and that is going to be abstracted away by something called the channel. So to open a new connection, I will use of course, a channel builder for a target I want to connect to. In this case, I'm going to connect to port 8080. Because this is for testing purposes, I'm going to use plain text. HTTP2 actually wants you to use TLS or SSL. But since I'm using Java, if I show you how to use SSL, we'll be here all day, so I'm not going to do that. And I'm just going to build this channel to use a plain text and be done with it. Now, in this here, we can also set a few different things. We can intercept the requests if we want to, so you can add interceptors. You can also add what we call the name resolver. So if you're running multiple microservices instances behind the scenes, given a logical name like hello world service, you need to figure out potentially which endpoints are actually serving it. It could be one or many. And to discover that, you need a service discovery mechanism like Zookeeper, Console, or Eureka. Well, to do that, you need to tie into a name resolver, and from there, you can resolve a logical name into the actual endpoints that you want to use. You can also specify how you want to load balance. We give you the round-robin load balancer out of the box, but you can implement your own load balancing strategy if you want to. Okay, so let's keep it simple for now. Check the time. I got like 15 minutes or so, and so this is going to give me a channel, and there we go. And now to consume the service, once you have the channel, it's really, really easy. I just say greeting service gRPC dot new stub. So remember, it's up to the client to choose whether they want to block or not. So we give you 3 choices. You can use the blocking stub, or the fully asynchronous stub, or you can use the stub that returns the future for Java developers, right? So I'm going to use the blocking stub for now. Blocking stub, there we go. And I'm going to pass in the channel. And that's it. And I can just get back the reference of the stub. I mean, introduce this variable. And I can just say stub.greet. Okay? You no longer have to copy and paste, all these objects and definitions and for REST, or just use like JSON object. Is there a JSON object here? Yeah, you don't need to do any of those anymore, okay? Because we generate all of these things for you, right? So I can say greeting with a hello request. I'm going to set my name to Ray, set my age to, let's say, 18, and I can put a back of tricks, and I can say live coding sucks. All right, and then add a hobby. I like to take photos, so I'm gonna say photography, and so on and so forth. Right, all of the simple types are set for you. So sentiment is, I can say sentiment is, I'm still happy right now. Right, so you can set all of these things, and then we can get back the response, and we can print it out. So any Node.js developers here? Yeah, I'm gonna use the favorite logger for Node.js, which is console.out. So in this case, I'm going to use print line. All right. I'm sorry. I had to say it. All right. Because I'm not doing it properly here. So anyways, so that's all I need to do to implement the client. I'm not even going to ask you the question because I don't know if it works. So let's see. So I compile. I did the clean it. There you go. Hello, Ray. And on the server side, yeah, live coding sucks. Yeah. Right, it's very, very easy to do it. Thank you. Wait, thank you. That was too easy. I mean, if once you understand gRPC, I took a long way to get here, right? Because I wanted to explain all the details. Once you understand it, I can do this in about, I don't know, like 5 to 10 minutes. Right? It's because everything's generated for you. You don't have to deal with making your own client library anymore. Now, to show you another side of it, the real power, is I'm actually going to do something a little bit more complicated. And what I'm going to do is I'm going to implement a chat application. So this is going to be real-time chat, okay, with multiple clients. Now, to do this, I am going to use a bidirectional string. So we saw the proto before. Oh, no. Don't delete anything. All right. So we saw a bidirectional stream. So I'm going to stream in the chat chat messages from the client. I'm going to stream out the chat messages to broadcasted to all the connected client. And I think I have about 10 minutes to do this. Okay. And to show you that this works, I will be running a Java FX application. So this is just a front end. And to show you that it doesn't work right now, it would be amazing if it works right now because that means I'm cheating, but it is not. Nothing is being implemented except for the front end. So I'm going to implement the server right now and also the client in a matter of hopefully 10 minutes or so. So we defined the IDL. It's bidirectional streaming. It generated this method signature for me. Okay. Now because it is bidirectional streaming, remember to send data back to the client, you need to use a callback interface. In this case, this will be the response observer. For the client to send data to you on the server, they also need to use a stream observer. But how? Well, semantically, we return a stream observer to the client. But remember, gRPC is based on HTTP2. So inherently, it is based on request and response. We're not holding onto any references like Corebot. Corebot has some really details that is just a little annoying for people. It's hard, that makes it hard. In this case, we're not holding on to the server reference. We're literally just doing this for convenience, right, in terms of understanding what's happening. So what that means is I need to return a new streaming observer to the client so that whenever the client sends a message, I can capture this message and I can broadcast it to all of the connecting clients. And every client will have this callback interface, so I just keep a reference of all the clients that's connected. And I can say observers.stream, and I can say for each of the connected client, I'm going to call all down on next. I'm going to give it the message from the server. Well, what does the message from the server looks like? Well, it's a message from server is equal to, oh boy, here we go. There we go. So I'm going to set the message from the client, and then I can set timestamp. I can set other things that I want to send from the server. But I'm not going to do that for now. I'm just going to do this, right? Yeah, that's pretty simple. So for all of the connected client, I'm going to send them the message I just received, broadcast. If the client sends me an error, this method will be called, right? This method will be executed, and you can actually see the exception. I'm going to do every good Java developer do when they catch the exception. I'll just do nothing. No, I was kidding. But in this case, I do need to remove the client from my connections, right? I want to remove it from all of the lists, so I don't need to send data there anymore. So I'm going to do that. And when I complete the connection, I'm also going to do the same thing. I'm going to just remove the connection. That should be it. Now I do see a little compilation error. I wonder what that is. Where is it? Do you see it? Do you see it? I don't see it. I don't see it. All right. Well, oh, this sucks. The only way to find out is to compile it. So let's see it. Oh, by the way, I also implemented the chat server, and as you can see, to start the server, there is almost nothing. Okay. So okay, I think that worked. I think that worked. You think that worked? I think that worked. All right. So that took about 3 minutes. All right. Now I need to implement the client. Well, how do I do that? I open up this JFX application. And don't ignore just ignore the code on the top. This basically builds the UI for me. The real thing is here when the application starts. We understand what channels are. We're going to open the channel to my chat server. I'm going to create a stub. By the way, this is a fully asynchronous stub. So what I can do is I can say chat service.chat. And remember what we sent to the server, an observer, so we can send that in. And what do we get back? We get back an observer, which we'll use later. Okay. So the first observer that we send in here, this is what the server will send to us. So whenever the server stream data to us, it's going to trigger this, right? So what do? Well, I can say messages.add, and I can do a string.format, and I can say who is it from, and what the message was, and I can just grab it from message from the server. And by the way, the reason why this is a little bit verbose is because I made it so. So it's not gRPC's fault. So I'm going to say get message from server and get message. Okay. So all I'm doing is to print this message onto the UI. And because I do need to run this in a different thread, just because of Java, I'm going to run this later. So blah. That's it. Okay. That's how you capture the stream from the server. And if the server gives you an error, I'm really not going to do anything today. All right. So you do nothing here and you do nothing here. The observer reference that we got previously from the server, that one, is what you use to send data to the server. So what I can do is whenever somebody click on the send button, I'm going to capture this event and I'm going to say observer.onNext. I'm going to give it the chat message that I want to send. Okay, so I can do builder. I'm going to set the from field from the name get text. I'm going to set the message from message.get text. And if I did everything right, that should be it. Now, how many people think this would just work? I'm going to ask one more time. Still less than half of the room? Wow. Well, let's find out. So you saw there was nothing there, and I'm going to run this. Live coding. I'm going to say Ray. Hopefully you can see it. Should I zoom in of this epic failure? I'm going to say, not the name again. I'm going to say hello, and oh, it works. Woo! Woo! That was close. That was close. All right, so now we're going to do something even more. I'm going to, I think I got maybe just a few minutes. All right, so I'm going to open up 2 windows now. Now, just so to show you that this is actually streaming to both clients. I'm going to be one of my managers. His name is Greg. He's awesome. I'm going to say, since he's my manager, I'm going to pretend to be him, complimenting myself. I'm going to say, good job, right? And of course, that works. I'm like, why, thanks, Greg. Do I get a raise? And it will be like, no, you just get to keep your job. All right, right? So it's very, very easy to do. Of course, I took a long way. Before I end, I just want you to let you know that there's much, much more. Specifically, I want to call out this item called deadline propagation. What that means is, if you have multiple microservices called A colon B colon C and so on and so forth, if the client doesn't want to wait, you can actually set the deadline. You can say, I only want to wait for 1 second for this whole thing to finish. If the first microservice A took half a second, B and C can only use the rest of the half a second. If you exceed the whole thing, we'll cancel all of the codes downstream, right? It will cancel all of them with the deadline. And there's a lot more that you can do with load balancing and server registering, health checking, and distributed tracing, and all the things that you worry about for microservices. All of those things are possible with gRPC. So with that, the reason I'm here is because, first of all, I'd like all of you to give it a try. Secondly, I want you to be able to contribute, either by code or by discussions and filing issues and telling us what you need. And the best way to do that is go to gRPC.io, contribute, or join us on the mailing list or the IRC channels. And if you want to see all the code I just showed you, you can actually go to gRPC Java demos on GitHub. And it's got much, much more examples than the basic things I just showed you today. So thank you again for being here, and I really appreciate it. Thank you. If you have questions, I'd be more than happy to answer. Or can you just grab me afterwards? Any questions? Yes, question back there. Yes, so it depends on your situation. The question is, how do you best share the proto file? It depends. Officially, I think a lot of people want you to share just the proto file in a dedicated repository and pull that in when you need it, right? But that's easier said than done in some cases. For Java developers, if you're using it not in such a polyglot fashion, you could just package up the client. So you can produce the client when you produce the proto file and then just give it to people. That's also a very easy way. Depends on how much control you want. You either control the proto file, you control the client library that you give it to the consumer. Okay? Yeah, question over there. How do you deal with version issues? Yeah, so good question. And with versions, gRPC in protobuf deals pretty well with versions. So I'm going to open up, before they kick me out here, I'm going to open up the simple server that I just wrote. And I'm going to show you the proto file. Okay, so anything you change is backwards compatible. What that means is you can change the field to first name, but you don't really want to do that, but you can. And as long as the tag number is the same, it represents the same field. Okay? But you can always add things. Adding things is always good. You can also potentially remove things. But when you remove things, you might lose. It will be sent, but you don't want anybody else to reuse the same tag number. That's what I'm trying to say. So if you remove one, you don't want to use one again. And to do that, you need to put in a reserve keyword, so reserve one, so nobody ever uses one again, right? Also, the last thing I want to mention is the best way to version, like major version changes, you should qualify it in the package. So if you want to deal with version 1, you put that in the package name.